challenge for the NASA rover challenge. It's a timed obstacle course and an engineering challenge. For the course, we have to have a rover that will fold up within a 5-foot cube. And they graded this one the #1 design in the world. There were 75 teams in 11 different countries. So they came around and they said, this one is awesome. If I had to take one to the moon right now, this is the one that I would take.
In this video, youth are guided through an engineering challenge with engineers. Watch and listen as the lead engineer encourages the youth to work through the challenge by using a design thinking process that includes questioning, brainstorming, making predictions, testing, and retesting.
They do require us to have non-pneumatic tires. Inflated tires won't work. You take that into space, the volume expands too much and it'll blow up the tires. It won't be any good. So an alternative that we're working for, solving one of the design challenges that have been proposed, is the airless result here. This is a sample of the potential tire that we will be using. You can play with it if you want.
So they have to be strong enough to ride on,
right,
but they have to be weak enough for you to crush.
Exactly.
Can I take this out?
Sure.
What is it?
The little pieces of plastic, it's 3D printed PLA plastic, and so you can print anything you want from the ground up.
That's cool.
It is pretty cool. We got some other material. The hardest part about the rover is the design challenge of finding the right kind of wheels. Exactly, because you often have to test a lot. You have to form a lot of prototypes and figure out what material is really going to work and what shape's really going to work. Keep testing and keep testing. Once you find something you think is going to be a solution, this one right here, you tweak it just the way you think you need to go to it, and then you test it. You can see the way we kind of went about our design process as far as modeling them. This right here is called a finite element analysis. With this, you can put in what parts of the material are going to be solid in place and they won't be able to move. And you can put in the material types and kind of edit the settings from there.
Which one's worked the best so far?
So far, the one with the plastic. The
Honeycomb one, maybe?
The honeycomb one didn't actually work too well. It was much too rigid. The support was too strong.
So you need to have 4 wheels, or?
We need to have 4 wheels. For testing, we can use just one. We can simulate the weight somehow with 150 pounds. I'm sure we have somebody in here that's 150 pounds, and they can just sit on it, and that'll simulate enough weight.
What was the best material to make it out of? Is it still the rubber so far?
Still the rubber. It's called a 2-part urethane. It's actually, you can see it out there, these 2 little jugs, you throw them together and it does something called vulcanized at room temperature. It'll heat itself up and solidify all by itself inside those molds. So that's why now we feel comfortable moving on to the testing phase. We've reached a decision here with the element analysis. We like what we see. So now we're going to test it. If it works great, we'll put those little plastic things in it and make it even better.
Cool.
It is cool, it is cool. We'll actually probably be testing them by Saturday. We'll have a full-scale wheel by Saturday.
I have a question.
Sure. Yeah.
Can you take it outside and let some people drive it?
We can probably take it outside and show you how it's done.
Get where you're going. All right, I'm actually going to do a curve right here.